All right, we are going to do the derivative of sine, cosine, tan, of inverse sine, cosine, tan, okay? So I'm going to show you how to do that. So the derivative of inverse sine. So first thing I'm going to do is I'm going to write an equivalent expression. So sine of y equals x, okay? Then I'm just going to make a little triangle to represent what's going on. So right angle triangle, y is my angle here. This is x over 1. Sine is opposite over hypotenuse. Use Pythagoras to complete my triangle. So this minus this, 1 minus x squared square rooted is that the size of that triangle. Okay, so now I'm going to keep going and I'm going to find the derivative using implicit differentiation. So I need to apply d dx to each piece. Okay, so d dx is I'm here to find the derivative of u in terms of x. Well, this piece is easy. This piece I need to replace d dx with dy dx, d dy. Those are equivalent expressions. So then I'm here to find the derivative of u in terms of y. So the derivative of sine of y is cos of y. So dy over dx times cos of y equals 1. So dy over dx equals 1 over cos of y. Now we have a little bit of an issue because I asked you to find the derivative of inverse sine of x, and I have an answer with a y. So what I'm going to do is look here. What is cos of y? So cos is adjacent over hypotenuse, right? So here's the adjacent. So this whole thing equals 1 divided by adjacent over hypotenuse. And remember, when I divide fractions, I flip and multiply. Okay, so dy dx simply equals 1 over the square root of 1 minus x squared. So the derivative of inverse sine is 1 over the square root of 1 minus x squared. Hopefully you will get to a point where you actually remember that, but if not, you can recreate this situation yourself to know what the derivative of sine is. Now, you can do the exact same thing with cos and tan. The exact same thing I just did, okay, and derive it. I'm just going to show you, and you're going to believe me, but you could derive the same thing. So the derivative of inverse of cos of x is minus 1 over 1 minus x squared. And the derivative of inverse tan of x is 1 over x squared plus 1. So these are things that you would be expected to remember, just like you guys remember what the derivative of tan x. You know that that's tan x secant x, okay? I actually don't think that that's the derivative of tan x. So let's just pretend that I remembered that the derivative of tan x is secant squared x. So this is one of those things that we would just expect you to remember, okay? But if you can't remember it, I just showed you how to derive it. So now let's do a derivative question that is not as simple, okay? So what I'm going to ask you to do is do the derivative of inverse sine, except my angle isn't just x, okay? So it's a little bit harder, but really not a big deal. So what you do is simply the derivative of the trig function. Remember, so it's actually the same rule. So the derivative of the trig function is this. Keep the angle the same. So the derivative is 1 over square root of 1 minus x squared, except I don't have x squared here. Okay. Multiplied by the derivative of the angle. We didn't do that up here because the derivative of the angle is just 1. So we did it, but we just didn't have to really write it. So then I have to multiply by the derivative of the angle, so 6x minus 2. So the derivative of inverse sine of this angle is 6x minus 2 all over the square root of 1 minus 3x squared minus 2x